What is it? Oh, the circles? Does anyone have a pencil? Today is 116. You are sitting in Algebra 1 class, and we are going to learn today how to solve systems, the third and final way for this class. And so systems today by the third method, which is called elimination. Elimination. Yep. My very bestest handwriting. There it is. Some people call this linear combination. That's starting to go a little bit more by the wayside. Elimination has been a little bit more adopted lately. It just sounds cooler and it's easier to say. So you're going to right away figure out where it gets its name. I want to just remind you that there are three ways in this class that I get paid to teach you how to solve systems. Number one is graphing. We did that. It's where you graph two lines and physically see where they cross. Number two is substitution. We've been working on that for a couple days. Sometimes people just call it the box method. And then number three is today. So after this, we kind of go into some word problems and how to use systems, but mechanically, this is the end of the road for this little unit. So elimination embraces the idea that in a system of equations, you can take one equation and add it to another equation, and you get a third equation that is also part of the system. It's amazing. But here's what it looks like in its easiest form. So we have 2x plus 4y equals negative 18. And then we have negative 2x plus 2y equals positive 12. So what we're going to do is, again, embrace the idea that I'm allowed to add straight down. It seems weird that that would be legal, but it is. You will do this all the time. If you proceed through more upper level math classes, you're going to do this quite a bit. And so to combine rows of a system together is perfectly legit, legal. You can multiply them by whatever you want. You could divide them by whatever you want, and you can add them together. So that's a new trick in our arsenal today. And I wrote this one as a fluffer puffer, like the easiest problem that I could come up with, because do you see something that happens if you were to add straight downwards?
Yeah.
What is it? There won't be any X's. Very good, Josh. So what happens is we actually just got an auto elimination. So this, you'll come back and think about this in 10 minutes and say, okay, now remember the fluffer puffer, or sometimes I call it like a level one problem. So what I'm going to do, what you're going to do is I'm going to draw this line. And remember, for me, this line is pretty important. That line signifies I'm going to do something, like I'm going to add these together. Okay, so putting that line there to me is like a statement. Here I go. I'm going in. Now, this is where it gets its name. When I add downwards, right here, when I add the X column, what happens? There's nothing left. There is where the elimination happens. When I add down the Y column, how many Y's do I get? So I get 6Y. I copy down my equal sign, and then I add down the constant column. And what is negative 18 plus 12?
Negative 16.
And what pops out is a little equation that a normal sixth grader could probably solve, right? So we take this system, this high school level problem, but by eliminating one of the variables, we create this little thing. And we, of course, can divide both sides by 6, giving us the answer that y equals negative 1. And we're now halfway done. Now, I said this the other day, and it certainly wouldn't have made sense at the time. I just threw it out there. The one thing I don't like about this method is that I don't have that little box to plug it back into. Even if you don't draw the box, you still have that first statement that says like x equals 2y plus 5. And that's a really convenient, slick place to put a number to get another number out. Like it's the easiest thing in the world. We don't have that because at no point in elimination would we ever have created a box. So that is the only downside to this. And like I said, this will eventually probably become your favorite method, but the downside will always be that there's a little bit more work on the back end. So what you do now is you just say, I have complete and total freedom to put this y value, because that's what negative 1 is. It's a y. I can put it wherever I want. I can put it in the top or the bottom. Which one would you guys choose, top or bottom?
Bottom.
Bottom it is. So what I'm going to do is I'm going to take negative 1 and I'm going to put it in place of y right where that arrow is pointing. If Josh wanted to use the top equation, he can do that. And mark my words, we will get the same X value here in about 30 seconds. Okay. I'm just usually going to pick the equation that looks the friendliest to me. Well, the smallest numbers maybe, or less negatives, or whatever the case may be. So that bottom equation, if I take this equation now and I copy it down here and do a little bit of substitution, it's going to say negative 2x plus 2 times negative 1 equals 12. And I normally wouldn't show that 2 times. I would just do it in my head as I go. I just wanted to get it there for the first one so you can see. You see it? It's just an easy equation now. So we're going to get negative 2x. We're going to multiply those two numbers together to get minus 2 equals 12. And then we're going to add 2 to both sides, get negative 2x equals 14. And then we're going to get x equals negative 7. And we are done. What made that problem so nice is at the very beginning, when I gave you this problem today, I made sure that there would be a variable that was ready to eliminate. Hence the designated name fluffer puffer. I don't care what you call it, but it's just ready to go. Do you want to guess what's going to happen in our next problem? Let me put it up here and then you can look at it and then you'll be able to answer that odd question. So here's example number 2. So we have negative 7x plus 4y equals 30. And then we have negative 2x minus 2y equals 18. What changed? What changed? There's a significant difference between this and the one we just did.
The X
If I try to do, I clearly did not do a good job on the first example. So let me try to use better words. In the first problem, when we started out, we added downwards and what happened?
there was no number.
The X's disappeared. Do we remember that? That was nice. That's what made this whole thing work, is that there was an elimination. When you look now at example 2, what's different? There's no elimination. You could add the x's together and get negative 9x, and you could add the y's together and get 2y. Does you no good at all to create a third equation in the system that doesn't get us closer to where we want to be. How do you think we can solve this problem? How about this? I'm going to point to a number and I'm going to ask you a question. Right at the end of this arrow is a number, and I'd like you to answer this question. What do we wish that was? If that were a 4, a negative 4, there would be an elimination, wouldn't there? We have the power to make it into whatever we want to make it. All we have to do is change it. And to change it, we have to multiply it. And in this particular case, we're going to multiply it and everything in its equation by 2. This is a level 2 problem. I can get away with just multiplying one of the equations by a number and then get it back to a level 1 problem where something eliminates, which is nice. So what I'm going to do now is I'm going to take the top equation and I'm going to copy it over because I am not modifying the top equation. So it's just going to be an annoying like 10 seconds that I can't get back. Copy it down. Now I'm going to rewrite bottom equation version 2.0 right below it to make it a level 1 eliminatable system. So how many x's will I get? Negative 4. Good. How many y's will I get? How many constants will I get? There you go. And yep. And now I'm going to put my line of intent. That line to me should not be something that we just casually throw around. The line is a statement of, I'm going to add the things above this line together. Now, again, incoming purple arrows. When I add downwards, how many x's do I get?
Negative 11.
I do. I get negative 11 x's. When I add down the y's, how many y's do I get?
Yeah.
None. Hence what we're doing. And then I'm going to copy down the equal sign. And when I add the constant row, or the constant column, what do I get? Dope. And again, as advertised, what pops out is an equation that probably anyone in this building, including 7th graders, could probably solve. We just divide by negative 11 and we get x is negative 6. And so as I always do, I'm going to write my final answer. I'm going to say the answer is now here, -6, comma, blank. How many equations do we have to choose from for places where we could put that -6? I would argue three. I would argue that you could put it in equation one, the original top equation. You could put it in equation two, the original bottom equation, or you could put it in equation three. Why did I not give this guy a label? Because it's the same as equation one. It's not uniquely different. So you have three choices. And again, I want to stress this every time I get a chance. Hannah can pick equation one. Jeff can pick equation two. And Surik can pick equation three. And if everything has gone well and does go well, we're all going to get the same Y because we're working within the same system. So at this point, which one would you choose, Peyton? One, two, or three? Two. It's what I would have picked. I'm going to gravitate there probably every time. I don't care about the negatives. I'm not scared. I like the smaller numbers. So we're all going to take equation two for the notes here, and we're going to copy that equation down. But when we copy it down, what are we going to change?
What's the X?
We're going to replace the X with an actual number like, -6, since that's what it is. So at the beginning of the green boxed equation, what is -2 times -6? It is positive 12. And then I copy the rest of the equation. And now I do math. What do we do next? Subtract 12 on both sides, giving us still a -2y equals 18 minus 12, which is 6. Divide both sides by -2, giving us y equals. Then there's our answer. Would you like to guess what happens when we ramp it up to level 3? As I did before, let me write the next question before I ask you those strange questions, because you just don't probably have any really point of reference on this. So here it is. Here's example number 3. This is an example of pretty much almost as hard as they're going to get as far as elimination is concerned. I'm going to go around this one by one, and I'm going to point to numbers, and you're going to tell me what we wish they were. Right there. What do you wish that was? Can you turn a 3 into a -5? Nope. Okay. How about this one? What do we wish that was? Can you turn a 5 into a -9? Nope. Not without using decimals and fractions. What do we wish this was? A -3. Again, ain't going to happen unless you're really good and you know how to multiply by like -3/5. No, thank you. And then finally, what do we wish this 9 was? So you can't turn a 9 into a -5 unless you use fractions. And so we find ourselves in a bit of a predicament. What do you suppose the solution is? You mean like physically change their places? You could like move the bottom to the top, but you're still going to be in the.
Somehow make the 9y into a thing.
Nope. You guys have done fractions. Do you remember fractions in grade school when what do you have to do when you add two fractions together? But what do we find? What's that thing called that we need? We need a common denominator. And this is exactly the thought process with this. We need a number that can come to it's what we call a common ground. So let's take 3 and 5, for example. Those 3 and 5 are stacked x's. What could I turn them both into where everyone's happy?
15.
Yeah, good. What about the 5 and the 9?
45.
If you wanted to. I would say 100 out of 100 people surveyed would prefer to work with the x's because we like 15s better than 45s. So I asked you, what could I do to this top equation to make that 3 into what I want it to be? I could multiply it by 5. But the reason this is a level 3 problem is because I can't just multiply 1 and be happy. That's what I was trying to show you, is that I also have to multiply the other one. And what do I multiply him by? 3 is not quite right. And let me tell you this, and you just said exactly what I would have said. I want them both to be 15s, huh? But what happens if you add 15x to 15x? What do you get? You get 30x, and I don't want that. So the idea is one of these bad boys got to take a switch, right?
So -3.
Let's do a -3. That's fine. Now, obviously, if I multiply them both by negatives, I'm right back where I started, and now I've got the same problem. So when you find yourself trying to eliminate a variable where they're both the same sign, just change one of them. Changing them both would be really dumb, right? Now, let's do this. Let's take that red number and let's distribute it and let's create an eliminatable system. We're going to morph this sucker now from a level 3 to a level 1, just like that. What's the top row going to say?
15x plus
Perfecto. In the bottom?
-15x plus 27y.
So just minus 27y equals -12. Makes you feel any better, Calvin? If I had $1 for every time someone forgot to distribute across the equal sign, I could probably pay off about half my house, bro. So try to remember that when you distribute, the parentheses are real powerful things. They remind us to go everywhere, including across the equal sign. Do you have any questions so far? What we have now is a level 1 problem. It wasn't written this way. We made it this way. And now I'm going to put my line of intent as if to tell the world, I'm going in. Here we go. When you add downwards, how many X's do you get?
None.
None. There's the elimination. When you add down the Y column, how many Y's do you get? Yes, you do. And when you add down the constant column, what do you get?
Negative.
And again, you're faced with something childishly insulting to your intelligence. Y equals 6. And just like that, I can construct my final answer down here in the corner. I can put a blank and a 6. And where, let me ask you this time, how many equations do I have where I could put that 6?
4.
I have 4 now. Because every one that you see, every white equation on the board is actually unique. Now, would I have you probably sent for a mental health evaluation if you picked one of these? Yes. Just because, all things being equal, if I have freedom of choice, why would I choose the ones with the much bigger numbers? So are they available? Yeah. Are you going to pick them? Man, I hope not. Who do we like of the ones on the left, top or bottom? That top one's pretty dang tasty. I like that top one. So I'm going to grab that top equation and I'm going to write it down here, but I'm going to change his y number into a 6. So it's going to say 3 times x plus 5 times 6, which is 30. And then I'm going to do a little kitty algebra. Yeah, we're done. How do you solve?
Well, that's like 31.
Get rid of that 30 first. Don't you dare divide this early in the problem, right? We're going to leave that 3x and then we're going to move the 30 by making it a negative. Now we're ready to divide by 3 and we're going to get x equals -10. And that is where the lines would cross. There's a level 4 and it's honestly a little bit stupid. It's really just one of the other levels disguised. But after this, I'll probably cut this and give you the assignment so that you can not have to listen to my voice anymore. But this is level 3.5 or something. Well, I have to ask because this is my job, I guess. But what changed? There's crap all over the place. So what happens with this particular level is we do not want to try to eliminate anything yet. We're gonna, you could, except that's not the method that we're doing today. I will say, Justice, if we were doing like graphing, I would love that. But for elimination purposes, not what I was hoping for. Do we all agree that this one looks a lot different than the other ones?
Yeah.
And because we're trying to attack it the same way we attack the others, my thought process is, could I make you look like all the other problems we just did? And the answer is, yeah, easy peasy. Here's what I'm going to do. I'm going to leave the -6x hanging out on the left side. Yeah. Let's start with the top equation first, okay? Did you say 8y? Because I don't want to talk about this bottom equation right now. We're going to just fix one at a time, and then I'll get to you, okay? Who's out of place?
8y and negative 34.
Yeah, there's two guys that are like, I'm sorry, you're going to need to put me back in timeout. Like escaped and went to the wrong side. So the negative 6x is going to just kick it and stay where he is. The 8y is like, "Hey, everybody, hold on a second. I'm coming over to the left where I belong. Change me into a minus." And then the 34 is like, sorry, guys, I'm the wrong room. My bad. 34 moves to the other side and becomes positive. It's just a little bit of house cleaning. It's nothing to it, right? Now let's talk about that bottom equation. Best I can see, there's really only one dude that has to move. Who is it?
Negative
It's
6.
that dumb six. This six is like, again, I'm sorry to crash the party. I thought this was a different house. So the negative 8x, I'm going to move to the front, not across an equal sign, so I'm not changing it. And then the plus 9y, those two homies are just going to switch places. So they're in the right order. We want everything to line up, right? And then the six is like, sorry, I'll show myself out. He heads to the other side and becomes a positive six. What level would you say this is? One, two, or three?
2, 3, 1.
It's a three, wholeheartedly, because there's not one number in this problem that I can change to be exactly the one above or below it, right? Like I can't change a six into an eight or an eight into a nine. And so we are now faced with a level three problem. So there's a right answer to this question, but you don't have to read my mind. Which variable really technically would be easier for us to kill? Nope.
Y.
Why do you think it's the Y's?
Oh,
And it's such a small thing, but here's why. You see how they're already opposites? That makes us a little bit less stressed out if we don't have to change signs. So I personally would like to kill the Y's. The X's, you could make a case the numbers are smaller. You could go either way on this one. Got it? So let's do this. We'll finish this and then we're going to get to work. So now that we've got our system in order, let's multiply and turn the 8 and the 9 into what?
72.
72 is the correct answer. God, does it help to have your basic times tables? Awesome stuff. So what am I going to multiply the top equation by? 9. And what am I going to multiply the bottom equation by? 8. And I don't have to use a negative because I picked the one that already had the staggered signs. And now we're going to create our final eliminatable system. What will the top row say? I need your help. I'm terrible with my multiplication. Negative what?
63.
I'm sorry. I couldn't. It sounded like you said 63, but
54.
Oh,
Oh,
negative 54x. Sorry, my hearing, Josh. It's a little rough right now. Negative 54x. And then what? Minus 72 of those y's equals, do you want the calculator? 9 times 34.
600.
It's 306. And if you want to try to do it in your head, I salute that. It's something that everyone in this room is capable of. 9 times 34 is just really 9 times 30 and 4 put together. What's 9 times 30? 270. What's 9 times 4? And your brain can handle all of this. 270 plus 36 is exactly what Zurich said, 306. So, or use a calculator. I don't care. Let's do bottom row. What's 8 times negative 8? Woo. These numbers are getting a little big. What's 8 times 9? Yeah, I kind of knew that was going to happen, right? Like that's kind of the whole point is to make those numbers the same. And then, oh, I need a calculator for this one. What's 8 times 9? 8 times 6, 48. And now I can draw my line. That's that line your third grade teacher or fourth grade teacher made you draw when you did your addition facts. Let's do this. Let's add downwards. I need your help. These numbers are scaring me. They're so big. Go down the X column. How many X's do we get?
Oh,
Negative. Dope. Let's add down the Y's. How many Y's do we get? None. Let's copy down our equal sign. Oh, Dios mío, estos números son muy grandes. 306 plus 48. We're not scared. right? We got calculators in our backpacks. We bought them like 4 or 5 months ago. We're not scared. If you divide both sides by -118, you get x equals a perfect -3. And now you make your answer and you say, okay, I got you. Final answer is right here. There's my x. I got to go find the y. Again, I would tell you that I would really question you if you choose one of these. So I'm just going to take them out of the pool. Do you guys like top guy or bottom guy better? Top it is. I'll take whatever. So if I take this top equation and I write it down, who's changing, x or y? X, because we know him. So we're going to do -6 times x, but x is -3, and -6 and -3 make a +18 last I checked. And then we're going to copy down the -8, y equals 34. And now we just better hope we've been paying attention for the last year and a half. What do we do next?
Get rid of the 18.
You bet. Not going to divide, are we, this time?
No.
That's what I'm talking about, Cal. So we get -8y equals 34 minus 18, which is 16. And then divide. And we get y equals, yeah. And that, my friends, is a complete and full lesson on how to do elimination. And now we practice. Okay? Right on. There, I unpaused my recording just to say this out loud. You know how I roll. I'm not a big go do it at home kind of guy. You figured that out about me. So what I want you to do is work for 5 more minutes, see as much as you can get done, and then we'll just put them away. You'll put them not in your backpack, but in the folder that keeps them flat and unwrinkled, right? And then Monday we'll get them back out and we'll resume the task. Any questions about that?
Wait,
Okay.
heck?
Task.
Oh. I got 100 point test.